Question 32. At which interval is f(x) increasing? So here we got the two equations. They give us a derivative, which is very grateful. Appreciate it. So you know what we have to do. We have to derive and find when derivative f(x) equals 0. Okay, so as you can see, first step, we look how to break the formula. So what breaks f prime x? So it's a number plugged in, makes this equal 0. So we have two x values. So how I do this is make both x values equal 0 because we're multiplying the two numbers, or two x's. So for the first one, it's pretty obvious. It's 0 and 1, right? Because if you put 0 into the function, 5 times x to the power 4 equals 0. And then if you put 1 in, 1 minus 1 equals 0. So these both break the function. So now we make our number line, right? We put our two critical points, and then we pick points in between these critical points and in between the infinities. So I got -1, 1 over 2, and 2. So now we must plug these back into the derivative and see what we get. And right now we're looking for positive and negative y values. So as you can see, we plug in -1 into the formula, and we get -1 to the power 4, which is positive. -1 minus 1 is negative. So 5 times -2 is -10, which means it's decreasing at this interval. Okay. So now we do it for the other interval. So the next interval would be 1 over 2. So 1 over 2 plugged in the equation is, so f prime 1 over 2, so 5 times 1 over 2 to the power 4 equals 5 over 16, multiplied by 1 over 2 minus 1, which is -1 over 2, which is also negative. So at this interval, it is also decreasing, as you can see. So now we look at it again. Now we got to get 1. We use positive 1. Or, my bad, we use 2. Sorry. So now we plug 2 into this. So we plug in number 2 in the derivative. We multiply it out, and we get a positive number, which means it's increasing. So thus, we know it's increasing. The interval will be 1, comma, infinity. So we look at this. Now we know it's 1, comma, infinity will be our interval where this function is increasing. So now on to question 33. What is the value of the function at the relative min? So to find the relative min, we know that it's in between the decreasing and increasing interval. So what number is this? So you look at our interval line, and you know it's between where it increases, or when it decreases first and then increases. So this point is 1/2, or it's 1. So we plug in 1 into the equation, right? X equals 1, we put it into the function, and we multiply it out. And we plug in the original function, and it ends up with the answer 1 over 6 negative. And that's our y value of our relative min.